Welcome back to the Circuit Revival, where today we're going to take a look at a Focusrite 2i4. Now, we had some success in the last video looking at a Native Instruments interface, but today we'll look at this Focusrite one. Now, I'm hoping that there's going to be some blown things inside this, because the listing said that it was working absolutely fine until they plugged it into a faulty USB port and it went bang. So I'm not going to plug it in just in case it does anything to my computer here, but we'll get it open and see whether we can see anything immediately. I'm sort of hoping if it did go bang that there'll be some clear, easy explosions on the board. So I'll fast forward through this, but we'll just get inside. Okay, so we're in. So to get into it, you just need to remove all the screws and everything off the back. And then there's two little tabs here on the top, which if you just feed them from the back, you can press down and you'll get to them. So we'll start just by taking a look around the board, see if we can see anything immediately. They said that it kind of got shocked by a faulty USB, so we'll see whether anything has gone bang. So I'll just start by taking a look around the board. There's some slight discoloration just on this chip here, but I don't know whether that's just sort of like standard, but we can take a closer look at that. There are two layers to this board, so we might need to separate it out to see underneath there, but I can't see anything that sort of stands out immediately. So what we'll do then is we'll pull the microscope around and we'll have a look. So there's also, it looks like maybe there's some damage on this component here. So let's get the microscope round and have a look. This is a W2N transistor, I think it is, so that should be easily findable. This one's a bit harder to find because you can't quite see the numbers, but it's 7519A. I found some images online of someone that had taken some of these apart before and could clearly take the number off of that. So I've done that, and I've had a look at the pin out, and pin 4, which is this one here, is ground, and pin 6, which is this one here, is the voltage in, because it goes 1, 2, 3, 4, 5, 6, 7, 8. So we can tell this is definitely a problem, because if we go to pin 4, which is ground, and then pin 6, which is voltage in, that is a dead short. So I think this probably is definitely our issue, and I think this also doesn't help. So I'll try and get some replacements of these in, and then we'll swap these out and see whether it fixes it. So this will be a couple of moments for you, but a few days for me. So we'll see you when the parts get here. Okay, so it's been about a week and our parts have arrived here. So we'll start just by swapping out. But I think what I'm going to do to begin with is there's a couple of capacitors around the area we want to get to. So I'm just going to remove those first because I'm fairly certain they go bang if they get a bit too hot. So I'm just going to pull out my desoldering gun and we'll get these out. We'll probably take this one, and this one, and then maybe this one here. Okay, so the desoldering gun is all up to temperature, so we'll just remove these one by one. As I say, it does tell us which way round to put them back in the board, which is good. So the first one is just here. And the way this works is it heats up to the temperature we set, and then it will... it has a little pump in it so that when you pull the trigger, it pulls the solder in with it. So we'll start just with this one here. And that should hopefully just pull out. And it's as simple as that. So there's one. We've got just this one. And they're all out there. We'll just pull the scope round. And here we are back under the scope where you can see those burnt components are. So we'll remove these and then we'll just double check to begin with that our short has gone. So to get these off, we're just going to use our hot air and a pair of tweezers. And I think I'm going to get a slightly thinner pair just so I don't knock anything else off the board when I do this. There we go, that's a lot better. I think I've said it before that these mechanic tweezers, they're great. They're really thin tipped, so you don't knock everything around the board. And we'll just take a note on the board here where pin 1 is. It's just on the top left of the board here, which you can see denoted just by this little white dot here. So we'll get our hot air. I think I'll just add a tiny little bit of flux to this just to help it along. Okay, so what was a little bit worrying there was just quite how easy they came off the board, which makes me think that maybe someone's already tried to replace these, because usually with leaded solder it takes a little bit longer to get off the board, whereas they feel like they just lifted up a little bit too quickly, if you ask me, which makes me think that someone's already put leaded solder on the board. Now, it could have been me. I don't remember doing it in the last video, or the beginning half of this video, should I say, but something tells me that someone's already tried to do this and they've just gone bang again afterwards. But we'll test to see whether that short has gone. So we'll find a ground. So we can see here that the short isn't actually gone. See, it's a dead short both sides of this. So it makes me think that the issue wasn't those, they were just taken out as part of the issue. But what I suppose I need to work out is which side of the board here the issue is on. Whether it's on the front side of the inductor or the back side of the inductor. Okay, is that a crack on that capacitor there? Let's just get a bit closer to that. On the top looks like a crack. So what we'll do is we'll just remove that capacitor and then see whether our short goes. If the short goes, then that is indeed a crack. If it doesn't, then we'll keep looking around. Okay, so what we've done is we've just pulled the capacitor just off the side of the board there, so that it's no longer in the actual path. So what we can do is test the capacitor on its own. If this beeps, then this is indeed the issue. No, it definitely looks cracked. So our short looks like it's still there. Okay, so we've alleviated the short on this side. Let me just realize that you guys are missing the ports up here, so let me just get the USB meter back for you. Okay, so you can also see a bit easier there now that that's at the top, but you can see that on this cap here. Okay, no, it's come back. Okay, we'll remember to put that back, but we'll keep chasing this short around the board then. Okay, that doesn't look too healthy either, does it? I don't know how we missed that. So that's just a bit further up on the board. And that very much does not look healthy. Okay, GALRBJ. Now I don't know what that is, but let's get that off the board for now as well, because that's clearly not helping things. And if that gets rid of our short, then we'll be able to replace the components we have got, but it looks like we'll just have to order some more things in. Now this is once again right next to a capacitor, so I think I am just going to remove that as well. Okay, we'll just remove this other capacitor then, and then this one I'm just going to leave off to the side just so I don't get confused with which ones are which. Okay, so that one is off as well. Let's come back under the scope. Oh, okay. Yeah, this thing might be toast actually. Let's just go back under muck. So we'll just have a look around a bit more then. Yeah, there looks like there's another version of that. So I wonder if that's for the 2 channels. See if we can just see under this board quickly. Okay, it doesn't look like anything stands out quite too much under there. So let's keep continuing on, and we'll remove these 2 components. Okay, so with those 2 removed, let's see whether our short has gone. So we were testing just up the top here, so if we come back up into this top corner. Okay, so we still have a short. Okay, I'll keep looking around and see what we can find. Okay, so the board's cooled down a bit. Let's just double check now that it's cooled down slightly. I don't think it has gone though. No. So it's still there. So I think what we're going to do is we're going to take the cheat approach and see whether we can find this with the thermal camera. What I'm going to do is just attach a wire to the board here and see whether we can see any hot heat spots on the board basically. Okay, so we're just here with the thermal camera then, so you can see here's the board. There's a bit of heat in there from where I obviously heated some bits up. That coil's quite warm, which is a bit interesting really, but that could just be because they were near where I replaced those parts, and because they're sort of metal, they've kind of taken on the heat. So we will just attach this. So I'm going to do sort of 1 volt. We'll do slightly less than 1 volt to begin with, and we'll work our way up. But we'll just put some current through this. And I'll just find a ground point to connect this to. Okay, and that immediately goes to 1 volt, to 1 amp, sorry. Let's just look around the board and see if we can see where it's getting hot. So there is some heat just on that component there. Let's add the macro lens. So that is, I'm not entirely sure, but it looks like maybe a capacitor. And then those coils are still warm. We got anything else? All the heat is going through this coil and that component there. So what we'll do is, if we just leave this on here, and I will undo the power spine, we'll see whether that heat goes away. Not as sort of immediate as I expected it might do, in all fairness. It does get quite localized when we attach it back on though. We'll take a look at that and see whether we can see anything in that area then. So this is the area that was getting hot. I don't know whether that's like a current sense resistor or something. I'm not really sure what that is. Yeah, I'm not really sure what that is there. But we can possibly try taking it off. Check for shorts in that area. See if there is anything there. Okay, so I don't think it's this chip here because this capacitor here runs into that. And you can see there's 800 ohms on that side and ground on the other. So I feel like this might be our culprit. Now, I just need to work out how I'm going to get to that because there is a lot of plastic in that area. I'll start just by taking off this plastic thing here. Okay, let's give this a go. Okay, let's see what that's done. Sorry, you guys missed that. Let me just... So I've just taken it off, but let me just flick back to the microscope now because I missed... Okay, so it's off now, but let's just see what that's done to our short. Okay, I think it's helped pinpoint which side the short is on though. Okay, I think the next step is to possibly take this chip off then. Because on this side, we've got nothing. On this side, that's showing 11 ohms there, but then if we come nearer this chip, it's down to 0.1. So yeah, looks like our next step is to take that chip off as well. And that chip is an SMSC USB 3343. Okay, that would make sense if they're saying that this is this went bang because they plugged a faulty USB into it. That's a USB chip. Kind of makes sense. So that would be the problem then, doesn't it? Let's see if we can get that off the board. So do we think our short is gone? Let's start at the side we were at originally. No. So that has not removed it. Then let's just test this side. Okay. Unless is the USB itself internally shorted? I suppose that's something I've not considered up until now. When they said faulty USB, I presumed they meant the port that they powered it from. I guess I've not considered they might mean the actual USB port attached to the board. We might be able to remove that and see if that makes a difference. So I think that's probably the next step, really, isn't it? Let's pull the USB port off the board. But whilst that's there, I am just going to test the pins underneath it. So I think the outside would be ground. Yeah, and then... No, okay, so these are the pins for the USB. And neither of those are short to ground, so I don't think it is the USB port itself then. So now that that's off, let's see whether we get any difference in heat from the thermal camera. We've taken the diode off the USB chip there, and we'll see whether we get anything different. Okay, so that is pulling significantly less power now. So this might not show. Just the two coils there heating up. They just look like heat spots from the hot air station. Okay, there was a heat spot down there. Just here. You can see that that might actually be one of those capacitors that I thought looked a bit suspect in the first place. So if we come under here, and then we inject voltage. Okay, what is that guy? See, that's now gone again, and then we'll do that again. Okay, let's find out where that guy is. Okay, so that is that other, the sort of like same chip that we took off that was clearly bulged. It's the other one of that. So the one that we took off originally was this one here. It was that chip there that is getting warm. So I wonder whether they've just both failed, but one failed a bit more spectacularly than the other one. But either way, I suppose that's the next logical thing to remove. Still a bit intrigued as to how quickly these are coming off. I figured they would take a bit more to remove. They do feel like they're just coming off a bit too easily. Where were we? Just here. So I'm still a bit intrigued by this capacitor here. No, I'm not sure. Okay, let's test for our shorts again. Do we think it's going to be gone? So we'll take our ground and then our capacitor. And our short is gone. Okay, so it looks like this thing took out a lot with it, in all fairness. Obviously some of these I can replace, but the other ones I'll need to order in. So what I think I'll do then is I'll get these capacitors back on the board. I might need to actually watch back the video now to know exactly which ones went where. I'll try and get this diode back on. I can't quite remember which way that was facing, but I can double check that. Then I have to look and see if I can get some replacements of these other chips that we've just replaced here. So I've got the USB chip to get back on, the chips that I had that I need to replace, and the capacitors. So let's start just by getting all the stuff back on the board that needs to be on the board then. Okay, so let's start by getting the USB chip back on, which is signified pin 1, that little white dot there. We'll get our hot air, get this pinned in place, and then we'll just double check those shorts don't come back, because there's still every chance that this is also still shorted, but I don't think it is because we had that cap that was here that wasn't shorted. Okay, it's a bit off to the side, but I think that'll be all right. And then the diode thing here, I need to work out which way that went. So I'll probably just need to look back over the footage quickly. So give me 2 seconds to... Okay, so I've taken a look and it was positioned with the line downwards. So I went on that way. I think what I'm going to do is rotate this back around again so that I can get in a bit easier. And then tack that down. So we'll just get a little bit more flux on there. Okay, so I've just reattached the USB and that diode thing, and I'm just testing for shorts again. and we still have a short. Now I forgot to test before I put the diode on, so we'll take the USB thing back off first, because I feel like that's more likely to be the issue. And then we'll test again. Okay, so I've just put the USB back on, and it looks like that is also shorted. I'm going to give that just a little bit of time to cool down, just in case it is as a result of heat in the board. But whilst that's cooling down, we'll just test across this diode. Okay, it looks like the diode is also shorted, unless this isn't a diode. The fact it's got like sort of a polarized line on it makes me think it possibly is. But you can see on each direction, so this bottom corner to the top, shorted, diagonally, shorted, across, shorted. So I think there's every chance actually all of the components there are shorted. So the USB thing is back on. Let's just double check it wasn't heating the board with that. Nope, that looks like that is also shorted. So we'll take that off the board as well. And then even with heating the board, you can see that now that that's off, we have somewhat of a normal reading again. So yeah, it looks like that whatever they plugged this into took out a load of things. So we'll put this off to the side for now. So what we've got is this diode thing, this USB 3343 chip, two of these GAL RBJs, as well as the G4KNX, that looks like. And then the original two things that we knew were faulty, which was the G4KNR. Oh, I wonder whether that might be G4KNR. Oh, that's good. Okay, so two of those ones that we've bought, and this W2 component. So the upside we've got is these three we can replace. I'm just going to have a look into these four. Okay, so I think that's about as far as we can get for now. I think I'm probably going to leave the capacitors off for a little bit, just because I don't know what else I need to reattach. I don't want to have to remove them again to get to the bits I need to get to, so I'm just going to leave them off for a little bit. I'll put them in a bag ready, and then I'll have a look about trying to get some more of these other components that we've taken off, because it'd be cool to get this up and running. I don't think it's going to be the easiest thing though. I'm not feeling too confident that there's not something else that's going to go bang as soon as we turn it back on. So once again, I will have a look, see if I can get the parts. If I can, I'll jump back in and update you. Okay, so I think I'm going to have to publish this one as a no fix for now because I can find some of the components. So the USB 3343 I can find, but the other components I'm struggling with. So I'm going to kind of put it out there to you guys, see hopefully whether you can find anything or help out. So I'm looking for the GAL, BRJ, and then whatever this is, the weird diode thing. Because I can't quite work out what they are. So I think what I'm going to do for now is call this one a no fix and park it off to the side. So sadly, that does mean that we increase this up to 7. And it does put us at 14 for 7. But hopefully you guys got some answers on this. But it's been an interesting one in saying how much of that was damaged. But thanks for watching, and we'll see you in the next one.